Alright guys, welcome to another video. And in this video, we're going to be doing a bi-weekly contest. And my audio is good, so yeah, so let's do it. Bi-weekly. And then I have a weekly contest 12 hours from now. So, yeah. I really hope LeetCode fixes their server crap nonsense this time. The score absolute adjacent character. And yeah, so there should be a -1, right? So 13 and 50. I'm not going out bounds or anything. Okay. Over all given points with rectangles. So this is the maximum width of each rectangle. So I guess the idea is, okay, so I sort. Oh, this should be auto. I don't know why I named it X and Y, but I literally don't care. X of 0, Y of 0. So then I just do this. And then I do search equal to 0. Yeah, just being greedy, so j equals I. So what is it? Okay. Point of j in 0 minus point of I 0. And then I is equal to j minus 1. So I believe that covers that case. Okay, taking a while, so let me read this. Okay, 2, 3, 2. This should be correct. Let me just proofread the question so that I don't miss anything. X equals 0. Must be satisfied for each rectangle. So, yeah. Yeah, okay. And this is a, I'm just gonna outdoor it here. So, okay. Hmm. Well, I guess I want pair of ints. Then I'll do edges. Okay. Edges. What the frick am I doing? So edges 1. goes to 0. Cool. AC. And let's do a priority queue from node 0. So this is literally just so hmm. So if negative d plus w is less than d of we also have to account for this up here, and let's do it like this. And yeah, I think that's it. Well, what? Okay, so what is the expected answer for negative 1, 4? That should be fine. 0, 1, 4. I hope I don't get screwed over by a timeout because of this. Should be fine. And then, what boundary element or maximum? Wait, isn't this just... Oh. No, never mind. This is a little bit different. I thought it was the maximum of the entire array, then it's trivial. But I have to think a tiny bit. Largest element. So 1, 4. Okay, so I think I'll do it here. I usually do Q4s on an editor. I don't know why, but so here we have number of subarrays. So let me just 1, 4, 3, and 3. So I pretty much want to. Let me eat breakfast. Let me think about this. Okay, so if let okay. Wait, actually, um, so if that implies everything in middle, everything in between is like lower equal, right? So that means they have to be the same. So, what's a bit? What's a? I was thinking of monotonic stack, but that doesn't quite work for some cases. So if we have 3, 2, and 3, 1, and 2, so 3, 1. Hmm, we process the values in sorted order, so it might be a better idea because out of 9. So my idea is So now I have this, and let me eat breakfast and think about this. Yeah, I'll come back in like few minutes. I'm back. So I believe I figured it out. And what I now want is this. So basically I don't need this. What I want is a okay. So P is less than this and it's less than this. Okay, so now we have this. And let's do the same thing. And I believe this is it. How do I do this joining process? Okay, so then, like, I guess what happens is if, like, so, hmm, so like, so if I join this element, some other ones, oh, wait, actually, maybe I don't need this last array because then, yeah, yeah, okay. I don't need this last. I just do, so unite, so do this, so unite, tp minus 1. So I don't need this last array dance. And I'll say cnt of I plus cnt of j. Something like this. And then I'll kind of do the same thing here. So do this. Whoa, what? Plus 1, then 4-inch p, ps. I'll do cnt u of that find is equal to 0. And I'll do cnt u of that find p is equal to 1. Then I join everything. Then I do that. So then I guess I need to keep track of the roots or something. Hmm. But then that would be quadratic, so then everything will be double counted, right? So then after I do this, I do answer plus equal to. Answer divided by 2. Oh shoot. I don't mean to do this. I'm gonna make this work in the future, but -1. How's that even possible? So do that, and where is it crashing? So if you do that, I don't understand why this is. How do I? How am I accessing -1? Because I checked for this, right? Like, that can't be it. Oh, because I forgot to replace the minus with a plus. Oops. Mm. Oh wait, this should be x minus 1. And no overflows, nothing like that. Okay, we just replace this to be an int and GG. So it took me a little bit for Q4 how to make everything work. But yeah, let's go through the problems. So here you just kind of do what the question says. You find the absolute difference. So you can just literally subtract the characters you get from indexing to the string like this, because each character is represented by ASCII value, right? So in C++, at least, each character will get converted to their actual ASCII value when you do subtraction or addition, whatever. So yeah, that's question one. Question two, there's this greedy idea where you want to use the rectangles as big as you can, satisfying this constraint. So the way you can kind of simulate this is you sort the points by their x. You don't have to care about their y. And I just did a two-pointer. So let's say I'm at the first element. I go as far as I can while maintaining this constraint. And as soon as I break this constraint, then J will be the first rectangle that I'll not be able to cover, or it's at the end. And I just add answer, I just move I forward. Then I start from the rectangle I can't cover, and I try something else. Try some other rectangle. So that's the greedy idea. So this is basically a Dijkstra where you greedily try to reach every node in the shortest time possible from a single source. There's this additional constraint where it has to get to the node before disappear. So you literally just code a Dijkstra and you check if the new distance is less than disappear. But otherwise, it's exactly the same as Dijkstra. So in Q4, the idea, well, I tried a couple of things. I tried a monotonic stack. I tried kind of like do a range query of the maximum value, but those rely. Okay, so the reason why monotonic stack doesn't work is because let's say I yeah, I go paint. So if I have a first element 5, 1, 2, 4, right? So to the eye looks like, well, we have one subarray here. But okay, so we have a 5. Now what are we supposed to do with a 1? Because a 1 itself can be a valid subarray. And what if we need like if, to look for a future 1? So like you have a 5 at this step, and then what do you remove the 5 and put a 1 in the stack like this, because you might as well maintain a monotonic property. But then I got rid of a 5. That means it's not going to get detected in the future. So that doesn't work. And what was the other strategy I tried? I tried, yeah, range query something. But that requires. Okay, so you can go through every leftmost index of subarray, sure. But where are your right indices you can end up at? So that makes a solution with range query stuff quadratic, because you simply don't know where the subarray is going to end. Like binary search is not going to work because there can be multiple places where you end. So then the right idea is do union find. So what you do is you process the values in sorted order. So if you have this array, you're gonna process all the ones first and all the threes. Well, all the ones, all the twos, all the threes, and all the fours. So let me go over to my editor. So I simply get the position of all the numbers and I go through them in order. Because when they iterate through math in C++, it goes from the lowest key to the highest key. And I have this unifying idea. The reason is like if I go back to the example 5, 1, 2, 4, 5, right? Maybe I'll put a 2 here. So I'll put a 2 and a 5. So I process 1, right? Pretty much nothing happens, just for sake of explanation. But when I have a 2, so I go through this 2, basically I want the components to have all the values that are less or equal to current value. So that means for the 2, what I need to do is I look at the adjacent neighbors and I see if either of them are less than it. So here I see a 1. Clearly it's less than 2, so I can join them together. And this is because maybe in the future, let's say some imaginary array, I have a 2 here, and it also sees this 1, and then I will just join it like this. And if I have something like this, right? Well, first, these ones will get joined together. Then 2 join with this one, and 2 join with this one. So this entire thing is joined as in one component. So that's the idea. And in each component, I want to find out how many of each number I have. So let's say I'm at 2 again, right? So I'm at 2. So this has 1, 2. And this guy, it can't really join with the other neighbors because they're all bigger. So you want to make sure when you go through the values, the endpoints has to be that it has to be same as the current value we're processing. So this is only 1. Right. And then same thing with 4. It's all by itself. Well, now we have this entire thing connected to a 4. But there's only one 4, so that's not much. But then when we have this 5, right? So this is what happens at 4. And 5 joins with that, and 5 joins with this. And we can see we have 2 counts of 5. So what that means is the number of subarrays now we can make with this 5, like the number of other 5s we can kind of pair with this one as an endpoint is 1. So it's basically CNT of 5 minus 1. And I do that for each 5. This CNT is maintained for each component. This is different than the size because we want to counter for specific elements rather than literally the size of the component. So yeah, so you can see I go through each position. I set this equal to 1 because we know that, well, the number with its own component has a count of 1. And then I try to unite all the neighbors are smaller equal. So I check for this condition and I unite it, and I also update the count array. And I go through each position again. So you may notice that if I process this 5, it's going to give me a 1. And this is going to give me a 1. So at the end, we're going to have to divide everything by 2, simply because we're double counting everything. So yeah, see, this x minus 1 is how many other of the same values are in this component. And I reset everything back to 0. because we want to get ready for the next value. So then this answer divided by 2, we correct the double count, and we plus n because we don't count an element by itself as the answer here, because then it makes dividing by 2 more complicated mess to deal with. So yeah, that's Q4. So GG boys.